Hey everybody. Sorry we didn't have class today. I just wanted everybody to be safe and this seemed like the easiest option. This is the lesson on probability and addition rules. It is the easiest of the lessons on probability. So I feel pretty safe with you having this lesson on a video and being able to follow it. And we'll follow up in class on Tuesday. Um, so here we go. There are a couple of things that you need to know about probability. Um, the first rule, major rule, will follow us throughout the rest of the semester is that all probabilities are between 0 and 1. If we have a probability of 0, that is an impossible event, cannot happen. And if we have a probability of 1, that is a definite event, gonna happen. Okay? Now, if we look at what's called a sample space, and I'll go over that in just a second. Um, when we look at all of the probabilities in a sample space, they have to add up to be one. So if you think about the flip of a coin, um, what can happen in the flip of a coin? You have two things that can happen. So the probability of each one has to add up to be one. Okay. So the sum of all the probabilities have to be 1. And just to bring back in some of that math that we did before, remember that the capital sigma means to add up. So that's add up all of the probabilities and you get 1. Now, what is a sample space? A sample space is just a list of all of the possible outcomes in a probability experiment. So if you think of everything that can happen in a sample space or in a probability experiment, then that's the list of all possible outcomes. So if we look at the sample space for the flip of a coin, what can happen when we flip a coin? Well, we can either get heads or tails. So the sample space would be tails or heads. Now, when we roll a die is singular for dice, the two six-sided cubes that you play Monopoly with or anything like that. What can happen when you roll a die? You get 1, 2, 3, 4, 5, or 6. So that would be the sample space for the roll of a die. Now, when we come to the roll of two dice, it's a little different, and I kind of have to explain why I have red and why I have green on this page. When we look at two dice, you want to have one of them different so that when you look at it and I see 1 4, I want to know that that's different than a 4 1. If we had two of the same color dice, we wouldn't know the difference between the two. So usually when you do these types of experiments, you have two different colored dice. Now, when you play a game of Monopoly, you do not actually talk about when you roll a 4 and a 1. You don't say, I rolled a 4 and a 1. What do you say? I rolled a 5. So the thing that you usually end up doing is with this, I have the list of 36 things that can happen, but I get the sums and not the actual dice rolls. So that's the one what we're going to use when we ask these questions. Now, I always go over this page because there's always somebody out there that doesn't play cards. So I asked this question on the test. So I want you to make sure that you understand it. If you look across the top, that's the things that can happen. And that's an ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. The suits on a deck of cards are clubs, diamonds, hearts, and spades. So that's like the different category for each card. Now, I want you to notice a couple of things about these cards. There are two colors. The clubs and the spades are black, and the diamonds and the hearts are red. Now, the jack, the queen, the king, you can't see very good on this page, but they all have faces on them. So we call those face cards. We will not be playing with the jokers, so there's not more than 52 cards. Now, when we look at the definition of probability of an event, if we just took the flip of our coin, heads or tails, what's the probability that we get a head? Okay, there's one head in the flip of a coin, and there's two things that can happen. So that's 1 out of 2. So the frequency of event A, whatever that might be, over the total number of outcomes in the sample space. So let's look at an example. All right, so if I look at the probability of the following in the family of 3 children, well, we've got to know what happens in the family of 3 children when it comes to gender. Okay, so the first question I ask myself is what happens when a family has 3 children in terms of biological birth gender. Okay, so 8 things can happen: boy, 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 girl, boy. You can go through the list. Now, that's not the important part when I look at these questions. I'm looking at the numbers in each one. So when I do that, I see that I have, like for the instance, I have 3 boys in the first one and I have 0 girls. So when I come over here to my question and it says, find the probability of getting exactly 2 girls. All right, so I'm going to highlight the ones that are 2 girls. So that one has 2 girls, so there's 3 of them out of my 8 outcomes. So that probability would be 3 out of 8. Now, when I look at exactly 1 girl, I'm going to highlight my 1 girls. And again, I have 3 of them out of my 8 outcomes. So that would be 3 out of 8. Then, at most, this is the way I like to tell anybody that asks me this question between at most and at least. At most is like the speed limit. Legally, if the speed limit is 55, that means you can go at most 55, which means you can go 55 and under. All right, so 55 down to 0. So at most would be the numbers 0 and 1. So if I want at most 1 boy, that would be 0 boys or 1 boy, and I have 4 of those. So out of my 8 outcomes, which would equal 1/2. When you're doing all of these, I want you to notice a couple of things. The way I've written this fraction, okay, because of the way you're going to have to put it in Blackboard, there's not a way to create a fraction in Blackboard, so you have to write it as just a horizontal. So you're going to put 3/8. And the other thing I'd like for you to notice is that you have to reduce all of your fractions. And so whatever you need to do to reduce your fractions, I will tell you on Tuesday that there is a way to do that in your calculator that makes life a whole lot easier. Now, if I want to do at least, at least is like the drinking age. If you have to be at least 21 to be able to drink, what does that mean? You have to be 21 or older. So at least acts like the drinking age. So if I want to be at least 2 boys, that's 2 or more. So that would be 2 boys or 3 boys. So there's 4 of those, so that would be 4 out of 8, and that gives me 1/2. Now, let's talk about that chart. All right, so we're playing a game of Monopoly, and I want to know what's the probability that I get a sum of 8. Well, if I look at this chart, it's really easy if you have like a marker or something. And I know we do most of our work on the computer, but sometimes it's good to write these things down just so that you can see. So if I look at a sum of 8, I can highlight the 8s, all right, and I have 5 of them, and there's 36 outcomes, so that would be 5 out of 36. Now, if I want a sum of 2 or 5, I'm just going to look at all the 2s and all of the 5s, so that means that I would have 1, 2, 3, 4, 5 out of 36 again. Now, I can ask any kind of question about this chart. And the next one says, what is a multiple of 3? And what is that probability? All right, so what are multiples of 3? Well, that's 3, 6, 9, 12, 15, 18, so forth and so on. But in my chart, since my chart only runs from 2 to 12, that would be 3, 6, 9, or 12. So if I highlight the 3s, the 6s, the 9s, and the 12s, that gives me 12 out of 36. And that reduces to 1/3. All right. Now, a sum greater than 8, I didn't write this on the page, but greater than 8 would be like 9, 10, 11, 12, and so forth and so on. So in our chart, I would have the 9s, the 10s, 11s, and 12. Okay, and that turns out to be 10 out of 36, which gives me 5 out of 18. Okay, now here's where we're going to talk about the complement of an event. So if I look at just this Venn diagram, I have a circle with A in it. So anything in the circle is event A. Okay, anything that is outside of that circle or in the yellow is what we call a complement. Okay, so think about it this way. If I say, what is the probability it's going to snow? And it was 10%. What's the probability it's not going to snow? Well, everything has to add up to be 100%. So 10% snow means 90% not snow. And what do we know about percents? 100% as a decimal would be 1. So let's think about this. I have the probability of A that it's going to snow, 10%. 90% it's not going to snow. That adds up to be 100%, which is 1. So the way that you kind of rearrange this formula is that you get the complement is 1 minus the probability of the event. So if all of this has to add up to be 1, then the white part is one thing, the yellow part is one thing, has to add up to be 1. So probability of the complement again would be 1 minus the probability of the event. So if I do these, and in here I don't want a number, I just want what it is. Okay, so if I want to describe the complement of the event, rains, does not rain. We win, we don't win. So if I look at the first one, it says I want to choose a red card out of a standard deck of cards. Then the complement of that event would be I choose not a red card. In other words, we choose a black card. Now, on the next one, it says out of 31 students in my statistics class, 15 are out sick with the flu. Well, if I have 31 students and 15 are out sick with the flu, then I would have 16 that do not have the flu. All right, and the next one says in my area, 91% of phone customers use Verizon. So if 91% use Verizon, that means that 9%, 100 minus 91, do not use Verizon. Okay, I hope that sort of makes sense because it's just, they're kind of like opposites of each other. Now, I say this every semester, and y'all, I have somebody that asks me the question every semester. This is the easiest question on the test. I promise. I don't make it hard. I make it very obvious, but there's somebody that asks, I don't know how to do this question. Okay. If you are worried that 35% chance that you will fail your exam, what is the probability you pass? Only 2 things that can happen. So we're going to do the complement rule. Okay. So the probability that I pass is 1 minus the probability that I fail. Okay. So probability that I fail is 35. So I'm going to do 1 minus 0.35, and that gives me 0.65. Or there's a 65% chance that I'm going to pass my exam. On the next one, this one's going to come up again when we talk about another part of probability, but it's the probability of none versus probability of at least one. Well, if you've got a list of things that can happen, let's just say I have 3 things that can happen. Either 0 of those 3 things can happen, 1, 2, or 3 of those things can happen. All right, so if I have 0, then I've still got 1, 2, or 3. So if it's not 0, then it's 1, 2, or 3. All right, so if we look at this problem, it says If there is a 5% chance that none of the items on a scratch off ticket will win, what is the probability that at least one wins? Okay, so again, this is a complement rule. So we're going to have 1 minus the probability of the event. So that's 1 minus the probability of none. And that's 1 minus 0.05, which gives me 0.95. So if there's a 5% chance that none of the items on a scratch off ticket will win, then there's 95% that at least one of them will win. Now here's where we have a conversation. All right. So we want to talk about what's called mutually exclusive or disjoint events. You'll hear those words used interchangeably. So I want to make sure you understand what that means. If it is a mutually exclusive event, that means they cannot happen at the same time. Okay. And I want you to kind of think about it this way. Can you be in South Carolina and California at the exact same moment? No. Okay. Now, there is a way that I could be in North Carolina and South Carolina at the same moment, but we're not talking about that. I want to talk about South Carolina and California. Cannot happen. And that's kind of like the two circles. Let's let A be California and let's let B be South Carolina. Okay. Those two things cannot happen at the same time. They do not overlap. All right. So I want you to notice they don't overlap. All right. That means that their intersection is 0. And you'll see intersection written two different ways. Some people write the probability of A and B. And in notation wise, mathematics wise, it is an N looking thing. It's an upside down U, just called the intersection. Okay. Don't want you to get that confused. All right. So if we have mutually exclusive events, has to only be mutually exclusive. Does not work for events that are not mutually exclusive. There's not a word for that. Just say not mutually exclusive. The probability of A or B is just the sum of the probability of A plus the probability of B. And again, if you have or, that is a union. So you'll see it written either A or B or A union B. Both formulas are the same thing. All right, so the probability of A plus the probability of B. So let's look at this one. It says on a used car lot, there are 8 Chevrolets, 11 Fords, 8 Dodges, 9 Jeeps, and 12 Toyotas. I cannot be a Chevrolet and a Dodge at the same time. Okay, so all of those things are mutually exclusive. It says, what is the probability that a car is a Dodge or a Jeep if I pick it randomly? So that's the addition rule. So I'm going to just put in words for what it is because it's easier for me to see. I want the probability of a Dodge or a Jeep. So separate it. I can say the probability of Dodge plus the probability of a Jeep. The probability of a Dodge there, if I add up all of those cars, I see that I have 48 cars. All right. 8 of those cars are Dodges. And then the probability of a Jeep, there's 9 of those cars that are Jeeps. So I would have 8 plus 9, and that gives me 17 out of 48. And that doesn't reduce. And again, you would need to put that in your blackboard as 17/48. All right. So if I gave you this one as a U try, it would be just a second, but we'll just go over it together. All right, it says Joe decides to randomly pick a shirt out of his closet to wear. Currently has 8 black shirts, 7 white shirts, 3 blue shirts, and 3 tan shirts. And let's see, 8 plus 7 is 15 plus 3 is 18 plus 3 is 21. So he has 21 shirts in his closet. What is the probability he chooses a black shirt or a blue shirt? Well, again, it can't be a black or a blue shirt or a white or tan shirt at the same time. So we're going to say that this is the probability of A or B disjoint. So the probability of A plus the probability of B. black or blue. So we're going to have the probability of black plus the probability of blue. So I have 8 black shirts, so that would be 8 out of 21. And I have 3 blue shirts, so that would be 3 out of 21. So that would be 11 out of 21. Now, if they are not mutually exclusive, that means that the circles overlap. And I want you to notice that I've got a little green part right here. So I just want to take 3 examples. All right. Let's say that on the left side, I have animals. Okay. And here are my animals. I want a bird, a bear, and a beagle. On the right side, I want things that fly. A helicopter, a plane, I don't know, butterfly. Okay. Well, butterfly would sit on the left side. All right. So I have a bird, a bear, a beagle on the left. So the things that are animals and things that can fly, they can go in the middle. Okay, so they kind of cover both circles. All right, so the bird would go in the middle, and then the butterfly would go in the middle, because those are things that both fly and they're animals at the same time. Okay, so I just want you to know disjoint means that the circles overlap. So you have something that fits in the left and it can also fit in the right. All right, now I also want you to notice that means that the intersection is not 0. So when I count things, okay, technically they get counted twice. Okay, because if I have them over here in the animals and I have them over here in the things that can fly, when I count them, I end up counting them twice. So what I have to do is I have to subtract them out once. Oops, and I skipped my page. What happened? Oh, it won't let me go back. All right, so here's the rule. You add and subtract. I don't know what happened. All right, it says, let's do the example. It says, Teresa is looking for a new condo to rent. Her realtor has provided her with a list of 17 available properties. Okay, so she's got 17 properties. That's our denominator. It says the list contains the following: 6 properties that are close to the subway, 7 properties that have low maintenance fee, 5 properties green space, 2 properties newly renovated. Then it gives me some extra information. It says there are 2 properties that are close to the subway and they have a low maintenance fee. Okay, and then you have 1 property that is green space and newly renovated. All right, again, 17 properties. If you add up all of these properties right here, let's see, 6 plus 7 is 13, plus 5 is 18, 19, 20. That's not 17. So we've got something going on with this and. Okay, it says she wants her to pick a first condo at random. What is the probability that the property is either close to the subway or has a low maintenance fee? All right, so, or, anytime you have an or, you have to ask yourself, do I have an and? All right, that's going to determine whether or not you use the first addition rule formula or the second addition rule formula. So this one says close to the subway or has a low maintenance fee. So I need to see if there's a close to the subway and has a low maintenance fee. All right, and of course there is. And I have it highlighted on the wrong thing, so y'all just have to forgive me. So, and low maintenance fee. See it right here? So we're going to use the second addition rule, and just because I couldn't show it to you on the video, here's the rule. It says the probability of A or B is the probability of A plus the probability of B. The first part is the exact same thing as if it were the disjoint formula. The minus the probability of A and B is the part that is exclusive to just the not mutually exclusive rule. Remember I said something gets counted twice. All right, so what you have to do is you have to subtract it out once so that it doesn't get counted twice. All right, so here we go. If I write this down, it says I want the probability that it's close to the subway or has a low maintenance fee. So you're going to take the probability of close to the subway plus the probability that it has a low maintenance fee, and you have to subtract out the and. Okay? So here we go. Close to the subway. There are 6 properties that are close to the subway. So 6 out of 17. Now, low maintenance fee. All right? There are 7 properties that have a low maintenance fee. So I'm going to add that in. Then I have to subtract out the close to the subway and the low maintenance fee. And there are 2 properties for that. And y'all, I apologize for it being green here. I had to make some things moving around because of my dumb little face in the video. So that would be 11 out of 17. Okay. I don't want you to get that confused just because the color's in the wrong place. But yeah, 2 properties that are close to the subway and have a low maintenance fee. All right. Now, the way that I ask most of these questions is using a table. Of course, you know me in tables. That's my thing. All right. So here we go. I want us to look at this table and kind of talk about it. When we look at this table, I want you to notice a couple of things. All right. If I look at the column totals, okay, that is down here at the bottom where it says total on the bottom. That is the total number of red, the total number of blue, and the total number of green. If you look at the row totals, that is the total number of tiger, the total number of monkey, the total number of lion, and the total number of giraffe. All right. Now, when you look at the information that comes at the beginning, it says there were 100 children asked. All right. So each of the rows and the columns should add up to be 100. So don't ever get that confused. Whatever is down here in the bottom right is the grand total. Okay. You've seen tables before, so you've kind of seen these things before. All right, so our denominator for all of these is going to be 100. When we do the next lesson, the denominator may or may not be 100. So it all depends on what you're doing for conditional probability. All right, so let's look at the first one. It says we're going to choose a child at random, and we want to find the probability of choosing a child who likes tigers. All right, so if I look at that, I see that 13 children like tigers. So my answer is going to be 13 out of 100. Now, I want to find a child and find the probability that I pick somebody that likes green. All right. Well, there are 31 children that like green. So that would be 31 out of 100. Now, I have an or there. But if you notice, the monkeys and the lions, they're in the same column. Okay. They're together. They're the animals. So I don't have to, it can't be a monkey and a lion at the same time. I hope not. So I'm just going to add the monkeys and the lions together. All right. So that's going to give me 23 out of 100 plus 31 out of 100, which is 54 out of 100. And again, I can reduce that to 27 over 50. All right. When I look at red and green, those are both colors. They can't be red and it can't be green at the same time. So what I'm going to do is I'm going to add red and I'm going to add green together. And I get 41 plus 31 and that gives me 72 out of 100. And if I reduce that, that gives me 18 out of 25. All right. Now, I want to look at who does not like giraffes. All right. So, not giraffe is like the complement. So, not giraffe in this table is everything but a giraffe. So, I'm going to add the tigers, the monkeys, and the lions. And that gives me 67 out of 100. Can't reduce that. Does not like green. So, I'm going to highlight everything but green. So that gives me 41 plus 28, which is 69 out of 100. Now, the last two are the ands. And this is where y'all kind of get confused because you want to add and subtract something. But this is the simplest one on the table. All right. We want to look at a kid who likes lions and their favorite color is red. So that's just where they cross. All right. If we look at lions and red, there are 12 kids that like lions and their favorite color is red. So that would be 12 out of 100, and that gives me 3 out of 25. Now, if I want to look at who likes monkeys and their favorite color is blue, all right? So I want to see where monkeys and blue cross, and that is at that 7. All right, so my answer is going to be 7 out of 100. Y'all, I could ask so many questions out of this table. All right, so just be aware that they can go from really easy to I can make them hard. All right, so let's just know that. But that's where most of these probability questions come from because it's easier to ask a bunch of questions out of a table. All right, so let's look at the next page. Now here's the one that's in the notes. The favorite animal and favorite color, that one wasn't in the notes. So that one's just in the video. All right. So, and I'll just add this video to, or I'll send you the PowerPoint so you'll at least have it. So if, let's look at this one, the one that's in the book. I mean, one that's in the notes. All right. So it says, suppose that after a vote in the Senate on a proposed health bill, the following table shows the breakdown of the votes by party. All right. So again, in this table, there are 100 senators. Okay. And so this column should add up to be 100, and this row should add up to be 100. So let's look at the first question. It says, if a lobbyist stops a random senator after the vote, what is the probability that the senator will either be a Republican or have voted against the bill? So the first thing we have is an or. All right, so here's where I have to go ask myself, is there an and? All right. First thing I can say, Republican or against the bill, we know it's got to be the sum of the two. All right. Here's where I need to go and see if there's an and. The and is where they cross. All right. And they cross at Republican and voted against. So I need to have the subtract part. All right. So now I'm just going to plug in that probability because it's really easy. It's the blue one, so I'm going to subtract 7 over 100. Now let's go fill in the rest of the formula. All right. How many Republicans are there? Altogether, there are 50 Republicans. So that would be 50 out of 100. And then I'm going to add the people that are against the bill. Okay. How many people are against the bill? 32 out of 100. Okay. And then it just becomes a simple math problem. That gives me 75 out of 100. So that would be 3/4. All right, let's follow that same logic for the next one. The next one says, if a lobbyist, what is the probability that the senator will either be an independent or have voted for the bill? Again, or. So I can write independent or for, and that's the sum. Now I need to see if there's an and the and is where they cross. And there is 2 independents that voted in favor. So I need to have the subtract. All right, so I'm going to go ahead and fill it in my formula. Now let's go and fill in the rest. So the next thing we want to look at is how many independents are there? Well, there are 6 independents altogether, so that would be 6 out of 100. Then I want to look at the 4s. How many 4s are there? Well, there's 68 of them, so that's 68 out of 100. All right, so then I just add and subtract. So let's see, that gives me 72 out of 100, and that reduces to 18 out of 25. Let's look at the last one. All right, the last one says we want the probability that the senator will either be a Democrat or have voted for the bill. Again, we have or. So I can write Democrat or for. So that's going to be the sum. Then I have to see if there's an and that would be where Democrats and for cross. And there's 23 of them. So since there's 23 of them, I have to subtract it off. All right, so I'm just going to subtract off 23 over 100, and let's go through the rest of it. How many Democrats do I have? Well, I have 44 Democrats. And then how many for people do I have? Well, there are 68 for people. And if I do the math, now, before I go on, and I know why I added this one, if I forgot the rule, okay, and I just said this is where I add them together, we know that there are only 100 senators. That was my grand total. What happens when you add 44 and 68? You get 112. There are not 112 senators. So if I added just the Democrats and the people that voted for it, that would give me more than 100 senators, which is impossible. So I had to have subtracted something. All right, so that's where we would have subtracted and gotten 89 out of 100. All right, y'all, the tables are really easy. The only one that can come into a little bit of difficulty is the one that has the or. And I wanted to make sure that I did some ors separate so that you could see. But I also wanted you to be able to see that you had tables that I could ask a bunch of questions from. There is a homework in Blackboard for you. I will open up the answers. I will put this PowerPoint in there so you at least have it so you can see. And if there are any questions, you can ask me on Tuesday. I hope you enjoy your weekend, and I will see you on Tuesday. Thank you.